So we're going to look at how to add and subtract rational expressions, which again are expressions where there might be a variable on the bottom of the expression rather than on the top only. But before we do that, we're going to look at normal everyday fractions, because the way we add and subtract normal everyday fractions is the way we're going to add and subtract rational expressions as well. So we look at these two fractions here. Before I put them together, I need to find a common denominator. I need to get those bottom numbers to be the same. That way I can put them both together. So I look at 3/4 and 5/6, and I ask myself, what can I make 4 and 6 into? What is a common multiple of each? Usually we want the least common multiple, but it doesn't necessarily have to be the least common multiple if you can cancel out after you add them together. So when I see 4 and 6, I think 12, because 4 times 3 is 12, and 6 times 2 is 12. So I'm going to go to my first fraction. I'm going to think, how do I multiply 4 into 12? Well, times it by 3. How do I get 6 into 12? Well, I times it by 2. And again, you multiply the top and the bottom. That way the fraction remains the same. It just looks different. Because if I change the fraction to be a different number, then I'm no longer doing the same problem. So I have to make it so that the fractions look different, but the values stay the same, which is why I have to do it to the top and bottom for each. So this would be 9/12. This would be 10/12. Now I can just put them together like normal, add your top numbers. 19 over 12. Make sure you don't add the denominators, because remember, when you're adding fractions or subtracting fractions, you do not add or subtract the bottom numbers. It's just the numerators. And this would be my answer. I can make that into a mixed number. I can make it to a decimal, but that would be perfectly fine to leave it like that. So that's how we add and subtract everyday fractions. The way we add and subtract rational expressions is going to be very similar. So let's take a look at one here. So I have these two rational expressions. I want to put them together. So I need to get their bottom numbers, or the bottom expressions in this case, to be the same. One's x squared plus 2x minus 8. One's x squared plus 7x plus 12. I need to get them to be equal. Now, unfortunately, I can't just add numbers to the bottom and add numbers to the top to get them to be the same that way, because adding doesn't preserve the fraction. So if I added an x to the top and I add an x to the bottom, it would not be the same fraction anymore. Now, if I multiply an x to the top and multiply an x to the bottom, then that fraction would remain the same. It would just look a little different. So before we can put these together, let's go ahead and factor the bottom pieces, because if I factor the bottom pieces, I'm basically breaking it up into what is this when it has a bunch of pieces multiplied together. So if I factor x squared plus 2x minus 8, I'm going to get a bunch of pieces that are multiplied together that would get back to the original expression, and then I can figure out what I need to multiply both of them by. So here we have 2x, x squared plus 2x minus 8. What does that factor into? Well, I have an x here and an x here, so I need to think of two numbers that multiply -8 and add to +2. Well, if I think of numbers that multiply to 8, I think 2 and 4. And if I make the 4 the positive one and 2 the negative one, that does seem to work out. Now I have to do the other one. So plus, bring this one down here, x minus 1 on top. Two numbers that multiply 12 add to 7. That seems to be 3 and 4. So x plus 3, x plus 4. Okay. So now I want to figure out, how can I make the bottom pieces the same? What factor is each bottom piece missing? Well, if I look at the first one here, I see we have an x plus 4 and an x minus 2. The second one has an x minus 3 and an x plus 4. So the first fraction is basically missing that x plus 3. It has everything the second fraction does except that x plus 3. And the second fraction is missing that x minus 2. It has everything the first fraction does except for that x minus 2. So I'm going to multiply each fraction by the chunk or the piece or the factor that it's missing. So the first fraction I'm going to multiply, and again I do this top and bottom to make sure the fraction stays the same. I'm going to multiply this by x plus 3. The second fraction I'm instead going to multiply by x minus 2. That way the bottom factors will all be the same, and then I can then add what's left on top. So now both my bottom pieces will be x plus 3, x plus 4, x minus 2. They don't have to be in that order, but they'll have those three chunks, nothing more, nothing less. So let's see how this would look then if I rewrite it. As I said, the bottom is going to be the same for each. So we have x plus 3, x plus 4, x minus 2. And then over here is the same thing. I'm going to write in the same order. X plus 3, x plus 4, x minus 2. Now on the top, remember when we multiply a binomial to something else, we have to do either the FOIL method or double distribute or whatever you want to call it. So if I look at the top of the first fraction, scroll up here a little bit, I'm going to take 2x times x, and that will give me 2x squared. Then I'm going to take 2x times 3, and that will give me 6x, and it's a positive 3, so I'll put a plus there. So that 2x gets multiplied to both the terms of the binomial. Same thing for the second fraction. I'm going to take the x times the x, and I get x squared. I'm going to take the x times the negative 2 and get negative 2x. I'm going to take the negative 1 times the x and get negative x. I'm going to take the negative 1 times the negative 2 and get positive 2. So everything in the first binomial gets multiplied to everything in the second binomial when I'm doing this. Now I have my two fractions. They both have the same denominator, so I can start adding their numerators. And this is the easy part here. The hard part is getting them the same. The easy part is just adding and subtracting what's left. So I'm going to make this into one big fraction here. I'm going to keep my bottoms the same. Remember, you don't add the bottom fraction, or don't add the bottom numerators, or the bottom denominators, I should say. So you don't add the bottoms. You just add the top. So I'm going to start with my x squareds then. Okay, we'll do some different color. I'm going to say 2x squared plus x squared is 3x squared. No problems there. Then I'm going to say 6x plus negative 2x plus negative x. So 6x plus negative 2x, that's going to be 4x because it's a negative. And then 4x plus the remaining negative x is going to get me down to a 3x. So plus 3x. And then there's nothing on the first fraction left, but there is still a plus 2 in the second fraction, so I'm going to have to bring that down because even though there's nothing to combine with it, it's still there for me to record. And this would pretty much be my answer. Now there is one other step you would have to take, and that is if you could, you would factor the top and get it so that it's split up like the bottom is, and then you would cancel the same factors on top and bottom if there were any. So you'd cancel it like we did with the multiplication and division of rational expressions. I can tell by looking at this though that it's not going to factor anything on bottom, and normally it'd be a pretty quick check to see if it will or won't. But if you can factor the top, if you see, oh, I can factor this, go ahead and factor it and see if there's anything that will cancel, and then leave your answer like that. Okay? But that right there is what we're going to be left with. Okay. Let's look at subtraction because even though addition is very similar to subtraction, subtraction does have one minor detail that tends to throw a lot of people. So pretty simple start. X over 2x minus 6 minus 4 over x squared minus x minus 6. So not as many terms going on in this one, but we still need to get the bottoms to be the same. So first fraction. X over, I can't factor 2x minus 6 the way I did the others because it doesn't have an x squared, but if I look at that, I see that I can take out a 2 from both those terms. So I can pull out a 2, let me do this in the here. I can pull out a 2, and then I can write down the bones of what's left. So, be x minus 3, if I divide both those by 2. So 2x, pull out the 2, becomes an x. 6, pull out the 2, becomes a 3. I remember pull out means divide. Bring down my subtraction. Put this as a 4. Now the bottom here I can do like I did the others. So two numbers, that multiply -6 and add to give me -1. Let's see here. Two numbers that multiply to -6 and add to give me -1. Well, 3 and 2 come to mind. And I need the x to be a negative, so I'm going to probably make the 3 negative because it's the bigger of the two. So I would do x minus 3 and x plus 2. Those would multiply -6 and add to -1. So now I go ahead and see what is each piece missing from the other. What are the bottoms missing from the other? What am I going to multiply by? Well, the first one has a 2 and an x minus 3. The second one has an x minus 3 and an x plus 2. So the first fraction is missing that x plus 2. It does not have the x plus 2. The second one does, so I'm going to multiply this by x plus 2, top and bottom. Now the second one has an x minus 3. It has the x plus 2, but it doesn't have just the normal 2. So I'm going to put that up here, times 2 times 2. So what happens to the top? Well, here, x times x times 2 gives me x squared plus 2x. But I screw this down here. Let's scroll back up. The bottom is just 2 times x minus 3 times x plus 2. Again, the order doesn't matter as long as you have all three factors there. This one here, 4 times 2, that's 8. And then down here, again, I have the same format. 2 times x minus 3 times x plus 2. Now I can start putting things together. So when I combine these here, go down just a bit more. I have 2 times x minus 3 times x plus 2. And on top, I have x squared plus 2x minus 8. Again, notice I put a minus 8 rather than a plus 8 because we are subtracting. This means that the subtraction sign here applies to everything in the second fraction. So if there was like another plus 7 over here or plus x, if there was a plus x there, then what I'd write down here is a minus x, and I combine it with a plus 2x. But this negative applies to the entire second fraction. Okay? But there is no x there, so I'm going to erase this here because I think we have one more step left in this problem as I'm looking at it here. Because what do we have right now on top? X squared plus 2x minus 8. And as I told you before, you want to check to see if you can factor the top. And that way, if anything can cancel, you can cancel it. So I'm looking at this here. I'm thinking two numbers that multiply -8 and add to give me positive 2. Well, positive 2 and -4, but that would give me a -2. So if I do positive 4 and -2, that would factor. So let's go ahead and do that. I would take the top part, give myself some space here, and I would say x plus 4 times x minus 2. And over here would be, again, just what I've been having. I really wouldn't do much with the bottom unless I'm going to cancel something. Make that 2 a little bit better. So now I have everything completely factored. I can check here and see that even though I could factor the top, nothing quite cancels. So I'm going to go ahead and leave my fraction like this because nothing will cancel. I've combined everything. This is as much as I can do currently. So when you're adding and subtracting rational expressions to summarize, you want to factor the bottoms, multiply each fraction by what it's missing from the other, and then add or subtract your top numbers. So 90% of the work comes from figuring out what you're missing and multiplying it by. 10% comes from the remaining combining terms. Hope you enjoyed the video. Have a good day.